So back to proving now using double angle. And so we have an option here. You can multiply both sides here and then apply the double angle, or you could straight apply the double angle. So what I like to do is always just start with what's given, which is the more complicated side, and we multiply it. So cosine x minus sine x times cosine x plus sine x, especially when they're giving you the difference of squares. So we know this is cosine squared x minus sine squared x. And then now you can use your double angle identity. So we know that cosine squared x minus sine squared x is cosine 2x. Therefore, we're done. We know that these are equal. But again, you could also have used the other side. So we could have taken cosine of 2x, replaced it with this, and said, oh, well, that is the difference of squared by factoring. All right, here, which is more complicated? 1 minus tangent squared over 1 plus tangent squared. Look familiar? No. And cosine 2 theta. So the right side is more complicated. So we know that that right side, this is how you use them, will either look like one of these three, which will then be our cosine 2 theta. So a little bit of simplifying to get there. Okay, so tangent, this is 1 minus sine squared theta over cosine squared theta. This is 1 plus sine squared theta. Remember, whenever you're doing these, you want to replace them in terms of sine and cosine. It's the quickest way. We have a lot of identities. And then this is now complex. So cosine squared theta, top and bottom. And then canceling. Remember, we're only multiplying one top and bottom, but I'm placing it here as reference. So this would become cosine squared theta minus sine squared theta all over cosine squared theta plus sine squared theta. And you always get excited when you see this one. We already know that this one is our Pythagorean identity, so it becomes 1. So cosine squared theta minus sine squared theta all over 1. And then we know cosine squared theta minus sine squared theta. That is our double identity, double angle identity. So this becomes cosine of 2 theta. We are done. Okay, let's try another one. So the right side looks more complicated, but what are we going to do here? Nothing, right? So on this one, it's better to apply your double angle identity. And how you're applying it is by saying cosine of 3 theta, and we can split them. Remember, we did one with the sum and difference property, where we had theta plus 2 theta, where you're allowed to split them. And so now we can use our sum and difference. And if you remember, cosine is selfish. So he goes first. And we put a minus because he's selfish, it's wrong. So sine of theta, sine 2 theta. And then now we can apply our double angle. So if we go back up, we can see that sine of 2 theta will be 2 sine theta cosine theta. And cosine of 2 theta will be one of these three. Now I want to avoid the 1, so we're going to stick with this one. Cosine squared theta minus sine squared theta. So cosine theta is cosine squared theta minus sine squared theta. And this is 2 sine theta cosine theta. And so we distribute. Cosine cubed theta, there's excitement, there's one of them. Cosine theta sine squared theta. And then 2 sine squared theta cosine theta. And there are no signs, so if we go now and use our Pythagorean identity, so if you notice we just keep going back and forth, we can turn these into cosine squared. All right, now it's just a lot of multiplying. So we end up with cosine cubed theta minus cosine theta plus cosine cubed theta minus And then this is going to be 2 cosine. So I'm going to take this 2, erase it, and place it over here to give us something to distribute. So this is 2 cosine theta plus 2 cosine cubed theta. And now we can just add them up. So 1, 2, 3, 4. We have 4 cosine cubed thetas minus 1, 2, 3, 3 cosine thetas, and we're done. So now this last one, we're going to be using factoring. So obviously the left side is horrible compared to the right side. So that's where we're going to start. Can you use that double angle over there? Yeah, that would be fine. And then do a little bit of modifying. But we can just factor. So if you look at each one, they both have a 2 and they both have a sine x. In fact, square is our common. So we can factor out sine squared x, which would give us sine squared x plus cosine squared x. And then we go, oh, sine squared x and cosine squared x, that's just 1. So rewriting this, we get 2, 1 minus cosine squared x, because this is our Pythagorean identity for our sine squared x. And then we're getting there. So obviously we distribute. And then we go back up and we look and see, well, we're trying to get 1 minus cosine 2x. So we need to have a cosine 2x. So let's go back up and we look. And this is one of the tricks that we're going to have to use. So 2 cosine x squared x minus 1, that would give us cosine 2x. So if we can modify this into 2 cosine x minus 1, cosine squared x minus 1, we will have our identity. So this needs to be positive. So how do we do that? We take out a negative. Now it becomes this. So we have our positive 2 cosine squared. Now remember, one of the tricks is that we can take this number and modify it. So we can do negative 1 plus negative 1. All right, and then we go back up and we look. Just keep comparing until we get what we want. So we need it to be 2 cosine squared x minus 1. So we need a 2, a cosine squared x, and a negative 1 to convert to cosine 2x. And we have that. It's sitting right there now. That's why I split them. So this right here is cosine 2x. So we have negative 1 plus 2, cosine of 2x. So remember, if you see numbers like 3 and you need a 1, you can just say 2 plus 1. You can always split them up. So we needed a negative 1 and we had a negative 2. So we can always say that negative 2 is negative 1 minus 1. It's an easy way to split it. And then we can say that that is cosine 2x. So now if we distribute, we get 1 minus cosine 2x. Does that match what we wanted? Yes, it does. And so we are done. And that's how we use our double angle. So with double angles, you'll be creating it and then replacing it backwards. And you're also going to be taking cosine of 2x and replacing it the other way. So you have to be able to go back and forth. The left and right are the identity. They are equal. So you can always replace any of these with this, and you can always replace this with any of these. Thank you.